Alrighty, does this work? You guys people in the back hear me? Great. Are you ready? Alrighty, cool. Well, great turnout. Thanks for coming. I'm just curious, how many of you were actually here for my last talk a year ago? Hey, that's good. I hope you come back for the third installation next year in 2017. And then the other question is, who has even heard of Rx.js? Oh, good. Who's heard about it through Angular 2? Okay, good. So as you might surmise by my questions is, Rx.js is going to be one of the main components in the new Angular version, and which doesn't mean that you can't use it outside. I've been using it now for about a year and a half, 2 years. And my computer's went to sleep. Don't do that. Don't go to sleep. So I've been using it mainly as a data processing pipeline. So let's just dive in and see what's up on tap today. So we're going to cover a wide range of things. They're mostly a little advanced, builds on my previous talk. I'm hoping I can give you enough details for those who see it for the first time to kind of get a sense for how things work. But I'm going to do a brief little recap. I'm talking about functional programming principles, which, as you do more and more with Rx, come in really handy. I'm going to talk about subjects, and then how you can build your own custom operators down the line, and how to do branching and do all those kind of fun little things that we're used to from our regular programming. So the one thing for those of you who haven't done Rx yet is, I kind of swiped this because it's kind of apt. It's think different. If you're used to having your code go from top to bottom and call a function here and there, this is going to be very different because everything we do in Rx is asynchronous. So you can't count when your code is in sequence that this one actually comes after this, or what comes after. So again, everything is asynchronous. It's a data processing framework. It's event-driven, and I'm going to have more to say about that in a little bit. And as I mentioned, data processing, it uses data streams. And again, this will probably hopefully become a little clearer in the next 5 minutes. And the big thing that sets it apart is it's functional, not procedural. So what I mean by that is that you're going to see a whole lot of functions tonight being passed into other functions, coming out of other functions, functions invoking other functions. You can create a function that creates another function. So it's all functions. And that's kind of the beauty of JavaScript and functional programming languages, that you can actually do that. So what does it mean? For those of you who are fairly new to programming, if you've done Node, you're probably familiar with the concept of callbacks. So that's the async, and you're basically passing a function that will get executed when something else happens. So concepts. Rx.js is built on observables. So the best way I can come up with, if you're not familiar with the concept, is if you go to one of those fancy little restaurants like Applebee's, they give you a little token, if there are no tables, right, and you put it in your pocket. That's an observable. It doesn't do anything, but every once in a while there's an event. In this case, it vibrates, it flashes, and hey, my table is done. Or it's ready, right? So that's kind of the concept. Now in programming, it really is an object, because we can't put buzzers into our computers. But we got 3 events to deal with. One is onNext. So basically that means the object says, hey, I got a new event for you, and here's some data. The next one is onError, which says something that you asked me to do went wrong, so I'm going to give the error back to you. And the last one is the onComplete. So this comes in when you have something that terminates. Let's say you have an array that you loop over. At some point, there's no more data values. So then Rx tells you, hey, nothing more to see, move on, I'm done, I'm complete. So each of the observables themselves are basically like data containers. So envision it like a container with a value inside. And you can get at that value initially. However, what you can do is you can pass functions into that container and apply that function to the value. And what comes out is another container. So you're kind of constantly cloning and creating new observables in the process. And in the process, you have that data and you modify the data, and that's where the whole data stream comes from. Excuse me. So, as I said, when you chain those operations, you can pass in, let's say you have 2 in there, you pass a function to double it, you get another one that says 4. And then you say another one that makes the negative, so you get another one that gets -4. And so you go through. At some point, that chain has to end, so you can subscribe to it, and you can subscribe to all of the events. So when you have an onNext event, which means all your computation is complete, great, you got your data, you can do whatever you want with it. There's also a graphic representation that's helped me a lot in the beginning. So each of these little dots is an on-next event. So basically it says, hey, I've got a data point. And they're plotted against time, just any kind of timeline. So as an example, and for those of you who've seen my talk, this is straight from the last presentation, we're creating observable from an array of 5 values, and it spits out an event for a 1, for a 2, 3, 4, and 5. And then as I said before, there's no more data, so it basically says, I'm done with the onComplete event. So that's how you would graphically represent this. For errors, you just put an X there to represent there was an error. So example time, and this is the exact same application I did last time, kind of lazy. But this is a Flickr search that runs on, you don't see a submit button, right? So it runs on every key push. So let's search for mountains. And here come the images. And I put an A in, and it does another search, and so forth. So that's kind of the thing as an example of what it can do. And I'm going to show you the code, if it'll let me. So this is the code that does it. Just real briefly, we're creating observable from an event. So that search box, whenever there's a key up event, it's basically, as I said, it's just an object that emits events, right? And you're used to it from your browser with click events or here key up event. It says, hey, there's an event. When that happens, that event gets put into a function called getCurrentInput. So it takes the event and takes whatever is in the input box and returns it. So now we have what's in the input box goes into search for images, which is a method that goes to Flickr, gets data back. As the data comes back, it goes into process API data because I want to format it somehow that I can use it. Okay, once that is done, now I have the data in a format that I can use. So I subscribe to it with an onNext method, and that's all there is to it. So the nice thing here is, if you read this code, you know exactly what's going on. The function names document what they do, and also the data flows nicely from top to bottom, right? And then if there's any kind of error, we have one error method here that handles all the errors. So you don't need at every step say, if this is null, do this. And then the next method you say, if this is null, do this, or if this is this, do that, or if that's that, if it's this exception, do something else. And here is the methods that I've been calling, and I'm showing you these just to see how really simple they are. And especially two I'm going to get to later, which is the getCurrentInput and the onNext. And there's two differences that I'm going to use to explain some functional basics. So in particular, pure functions and currying. Everybody know what that is? And I can skip that section? All right. So pure functions. When I started with functional programming, everybody said, oh yeah, it's just like math. You know, you have a function and you pass same values in, and you always get the same values back. So I'm just, okay, how is this useful to me? If I have math, right, and say x plus y equals 2, it's pretty easy, but in the browser we have events, we have API calls, we have UI elements, and just how does that apply to anything that's actually useful? So I'm going to show you another pure function, and this is the one that we just had just a second ago. So basically a pure function means that it's not relying on its environment. If you look at this function, everything it does to its parameter, right? We put in an event, and we get the target attribute, and from that we get the value. So if you pass in the exact same event, you're always going to get back the exact same value. Kind of obvious, right? But as opposed to an impure function. So this here is an impure function. We pass in a value, and the first thing we do is we assign it to some kind of buffer somewhere in the environment. We don't know where it is. That means we're modifying something else, something outside of the function. On top of that, we're reaching again into the environment for a state. So now if I were to ask you, if I pass this function the number 4, what's going to come out of it? Right? It depends on state. We don't know. So in essence, you have to have this in some kind of class constructor and an object where we have these values defined. So now if you pass in 5, you get back 9. unless somebody else changed state to say, hey, I'm a string, at which point you would get for, hey, I'm a string. Right? So you can already see how this is really complicated to think about, because now you have to think, what is my state and what am I going to get back out? So that's the beauty of those pure functions. They don't rely on anything on the outside. And that makes them really nice and reusable. Right? You have one function that takes an event and gives you back the value. You can put that to that controller, another controller, somewhere else. Really nice. Also, it's really nice to reason about. It's really easy to figure out what this function is doing. I don't have to figure out anything about the environment, none of that. And easier to test as well, because we don't have to set up a whole environment just to test our function. Right? It's really easy to test. And did I mention that they're easier to reuse? And this reuse thing is really one of the biggest things in Rx, because you're going to write lots of little functions that only do one thing but do that extremely well. And then you take those functions and through Rx you piece them together and you get an output. You take those same functions in a different way somewhere else and you get a different output. So rather than having objects that now interact, you basically have your functions that do the work for you. So pure functions is great. Let's just say for argument's sake, in the browser you have something like this. All that this does is you pass in a property you want to grab from the location object. Let's say you want to get the search property of your URL. Right? So we pass in search, window location search is defined, and return the value. That's an impure function. Right? We have to have the window around. We could rewrite this by passing in the window. Now we have a pure function. Right? We're passing the window in here, and we get the exact same code as before, except now the function doesn't need to reach into the environment. Does that make sense? Great. Anybody spot a problem with that function in regards to Rx? Go ahead.
Something has to pass it through the view.
Exactly. So now we have two properties. Rx only passes you one, right? You get one value out of the previous one into your current one. So how can we do that? In fact, if we think about this, what we're really doing here is we're configuring our function with a particular window object. So the answer to that is currying, and that's a big word. Actually, I think there were two guys. One was Curry, an American. The other one was actually, I think, a Russian by the name of Schönfinkel. And who wants to call it Schönfinkelization? So you just ended up with calling it currying. But the principle is, let's say we have a function to multiply two values, right? Pretty straightforward. It's a pure function. We pass in A, we pass in B, and we get the value back. So now let's say you want to write an application that competes with TurboTax, and you say, I'm going to do my MVP, and I'm only going to do Minneapolis. So you always write, okay, to get the tax rate at A, I always type 0.07775. So you basically have this code all over your place, which is kind of silly because get tax and multiply basically do the same thing. So is there a way that we can express get tax as a way of multiply? And the way to do this is with currying. So let's rewrite our multiply function by taking only one parameter, but now, and I warned you that we're pushing around functions all over the place. Rather than returning a number, we're actually returning a function. So now you have a function, you pass the second value to that function, and now we have both the values and we can do a multiplication. Looks silly, really powerful. So this is how you would invoke it. Looks really, really weird, and I hardly ever have seen anything like that, because normally what you would do, now you can say, here's my getTax method. I can pass it only the first parameter, the 0.07775, and I'm getting a function back. And I've basically captured the first value, the tax rate, and now I can call getTax with 120, and it executes this and gives me everything I need. Go ahead.
Is there some assumption that you're making where the nested function is considered pure still?
Ideally it is. Because otherwise you run into the whole thing where if you wanted to apply this multiply, which is a very, very basic function. You rely on something that's somewhere in the environment. You have to make sure that every single function where you use it has that environment set up. So, you definitely do want to be pure with this. And remember that that's part of the reason of making methods pure is to curry them so you can capture parameters, and in the end you pass one parameter and you're good to go. And I'll show with an example how that works. So anyway, good question though. We have our get tags from Minneapolis. Now you expand to Chicago. Pretty easy. We just say multiply 0.0925, and that actually has the Chicago tax rate. Nice, huh? Anyway, so that's about currying. How would we use it? Let's look back at our little example. So we noticed here the onNext function. And I warned you that, I talked about those two because there's a difference. You see that onNext is not pure. We have some kind of object here, in this case a rendering library, where we're executing a function on. So it's not a pure function. Let's go make it into one. We're currying it by saying the first parameter is the rendering library that I'm going to be using. Okay, and then the function that comes out is the image data that Rx is going to supply. Actually, let's go forward. So now we're using it down here, and you can see how we're essentially configuring our onNext function with the same object we had before in there, common. This is now renderlib, so now we have common.renderPhotoList, which is exactly what we had here. There's an added benefit. So now, this is the image search that displays the images. Now let's say your manager says, we just want to have a list of the images, and you just go, oh, okay. Well, really easy. All you do is pass a different object that renders a list rather than the object. So now your function can actually be reused for multiple different purposes. So that's kind of the power of currying, and you're going to use a lot of it if you're doing more and more Rx. So I can't hear what you're saying.
What happens when there's an exception on the process API call? Like there's an exception in the second before the next?
Right, so let's say the inner function throws an exception, then Rx sees that exception and propagates an onError event. Right, so normally you get the function returns something, and that gets propagated as an onNext event.
So the chain doesn't get broken or anything?
Get broken is the wrong concept. What's happening is your function throws an error. Rx says, okay, I've got an error. Excuse me, too much soda. And rather than saying onNext, because there aren't any data values, right? Now it emits an onError event. And that onError event, the next observable says, oh, you don't have data from me, you have an onError, just passes it right through. And then it goes through and it goes through and it goes, so everything else gets bypassed until you subscribe to it, and then in the end you have your onError method in the subscribe that gets called, and that's where you can handle your error. Okay, so here's one thing you could do is, let's say you have a function that needs to do something different for one domain versus another, and this is a totally silly example, but I think that's something that's easy to wrap your head around. Right, so we could pass in a host, and you can see down here, do for host name, we pass in window location host, and if it's sub-example, we're returning something. If it's something else, we're returning something else. And we can also, for testing purposes, we can pass in whatever we want. It can be a string, it can be some kind of property. And then if you're on the node side, and I've had to use it a lot where I'm going through my data and suddenly I have to go and, oh, darn, what's that query parameter I have? So now you need to have access to the data in your stream and your query. So you pass in your request object from Express, you get your stream data from Rx, and you're happy to go and merge them and do everything you need to do. And again, so the giveaway for curried functions is if you have something like this in your Rx operator. The Rx operator being here a map. All right, we still good? Great. So I didn't know how to make a clean transition, so I'm just going to go jump right in here. Let's talk about subjects. So far we've talked about observables, right? It's that data container where you pass functions to and it just changes its value and keeps going. And they emit events. Great. So far so good. For the observables, something needs to observe them. right? Because if you throw in events and nobody's listening, it's kind of like a tree falling in the forest and nobody hears about it. So you need to have observers, and subjects are both observers and both observables. So that makes them really powerful because you can go and you can use them to buffer your events, you can write your own operators with them, you can mess with the timeline, and I'm going to show examples of how to do that. So let's start with one on an example basis. It's called the replay subject. So if we're looking at this code over here, this is how you would create it. Over here is a buffer size, and that will become clear in a moment. So the first thing we notice is how you can get data into a subject. You just call the onNext method, right? We're self-consistent here. You call the onNext, and you get data in. So I'm passing it three events, three pieces of data, and then I'm going to subscribe to it, to the onNext event. And whatever the subscribe gets will end up here in this text box. Okay, so after I subscribe, I create another onNext, and then this little tidbit down here basically emits a number every 500 milliseconds, starting with 0. So I'm taking 6, so it's going to count 0, 1, 2, 3, 4, 5. So let's see what happens. Okay, exciting, right? So what's happening is I'm subscribing, and I see that I get all my data out. So if I set the buffer to 2, anybody want to wager a guess what's going to happen? Okay, let's see what happens. Now I got 1, 2, 3 YYZ. So what's happening is I'm sticking in event after event after event, but my buffer only holds 2 events. So that means by the time I subscribe, I only have the 1, 2, 3 and the YYZ. And then everything after that gets put out. Let's try this with 1. What's going to happen? Everybody now. YYZ. Let's see if you're right. Perfect, right? So you can have a different buffer, and what you're actually doing is you're reaching back in the timeline. Because by the time you subscribe, these events already have happened. Yeah, go ahead. No, it's purely first in, first out, because if you think about this as an event stream, you don't know where your events end, right? So what you could do is you could call uncompleted on this and say I'm done, and then I'd have to think how to do from the back. But pardon me? Yes, and thank you for that. You can also subscribe at any point. So let's go and see what happens if I have a delayed subscribe to it. So it's the same code. Let's set the buffer back to 3. So on the right side now, I'm resubscribing to that same subject. So I'm basically doing this again, but I'm delaying it by 1100 milliseconds. Okay, so let's see what happens. All right, so the first one, again, we get everything, but since we've delayed by 1100 milliseconds, after 1100 milliseconds, we will have had 2 of these events. So the 0 and the 1, which means that we should get another one, 0 and 1, and then that's exactly what we get. Pretty straightforward, right? So let's look at it on marbles. And if you're still a little shaky, maybe this will explain it. So here is our original thing. We're pumping in the values. And when we subscribe immediately, we get all the events. Now we're subscribing again. And in this case, we have a buffer size of 2. So we're only getting the last 2 events back here. And then we get everything afterwards. So it's a really nice way to reach back and say, let's say you have a running average. I need the last 5 values to calculate my running average. You set the buffer to 5, and you get always the last 5 elements to go through. Okay, different subject. Because you've noticed that we don't get a default value, so we always get a value. And the behavior subject resolves that. So here's again the code, creating the subject, and then I delay my subscription by a value that's equal to this. So in this case, no delay. And I'm doing the same thing, I'm emitting values every 500 milliseconds. So if I don't have a delay, which means I subscribe immediately. I won't have any of these events yet, so I get my default value out. And then afterwards, it just does my 5 little events. So if I now go to 510 milliseconds, I guess you can guess what's happening. Now, this one will have emitted an event, so I have a buffer of 1, which is my last number, which is 0, 1, 2, 3, 4. Right, and then let's say I'm delaying by 1400, so now 2 will have passed, and you should notice that 1400 is our delay, 1500 is the next event, so you should see the 1, 2 really fast, and then it should go into 3, 4, 5. 1, 2, 3, 4, 5. So again, you're reaching back, but you can provide a default value. Sometimes, you don't want to divide by 0 or always have a value. That's how you would do it. So here's the marble diagram. We have our default value. You subscribe immediately, you get the default value in every subsequent event. You subscribe later, you get the last event, and then every subsequent event. So why is this even helpful? Why do I bore you with this? We're going to use it. So let's take an example where you're, again, spitting out numbers. You're taking 5 numbers, and you're storing it in a variable. So now I have this observable. And what I'm going to be doing is I'm going to subscribe twice to it. And let's see what happens. It looks nasty, doesn't it? Because we subscribe once, sub1 gets a 0 and executes this on top. But also, as sub2 subscribes, we're rerunning this code for every subscription. So if this code would do encryption, decryption, and do an asynchronous call and do some other stuff, we would basically be running that code every single time. So in the case of an API call here, you would ping the API twice. Once for this subscription, once for that subscription. This is the same code, except now we're populating a replay subject, and then we're subscribing to the replay subject instead. And now it's what we expect, right? We have execution exactly once, and then this buffered value gets pulled out every single time you subscribe. So you're saving yourself extra work. You don't overload your server with API calls. So that's why we'd use them. Allow duplicate work. As I mentioned, they allow you to reach back in the timeline. And sometimes they're the only way to make things work. I had a case, how many of you were here at the last presentation about Auth0 and OpenID Connect? Right, so you remember that you talked about a code coming back, you log in, there's a code coming back that you then exchange for the user information. That code is a single-use code. So if you did what we did before, your first one will succeed, and your second one, Auth0 will say, that code is invalid because it's already been used. So in that case, your only way to use it is to use a subject. Those 2 previous subjects are nice. However, when I do API calls, I mostly use the async subject. And as the name suggests, it's mostly for async work. So here's how you would create it. I'm going to get into this a little later here. And here we're doing the exact same thing. Every 200 milliseconds now, we create a value. This one logs it out into this little text box. We stick the value into the async subject, and then we subscribe to it, and whatever comes on the subscribe gets into this big box. So let's see what happens. Well, that's interesting. You see this one here counts up. So what's happening is we're getting a new value here every single time, and it goes into the async subject, but nothing comes out. Right? But it does get logged out here. Well, that's weird. So let me push one of my buttons, one of your buttons maybe, send the uncompleted, which is this one here. So we're sending an uncompleted event to the async subject. Oh, that's interesting. Now I've pushed uncompleted and I get a value, which happened to be the value right as this was counting. So it was the actual value. That's interesting. So maybe that's how we get the values out. It's uncompleted, but no such luck, because once we complete it, right, as the name suggests, we're done. But what's going to be really interesting is, as we subscribe again, anybody wager a guess what's happening? right. We're getting the same value out. And you notice that we keep calling the onNext on the async subject. But as soon as we've called the onComplete, the async subject holds on to its value. And no matter what you do afterwards, that's the value you get. And that's kind of what you want, right? You do an API call for data, you get the data back, and you want to hold on to that data. Whereas with a replay subject, if something else comes in, that data will be gone, and your new data will be returned. So I can do this any number of times. I always get back 148. So here's the marbles for the async. I'm giving it on next events, nothing happens, and I'm subscribed. On completed, I get my value and I keep going. As soon as I subscribe, I always get the last value back. And we're going to see those a little bit when we talk about custom operators, but how am I doing on time? Actually, more importantly, how are you guys doing? Yay? Tired? All right. So let's talk about one of the things we take for granted when we're normally programming is it's branching, saying if, else, all those little operators. So, yes. So combining data. Sometimes you have two streams. Let's say you have an API call and you have some other data and you want to combine them. In my last talk, I talked about the zip operator, and it's basically taking two observables, in here R&D and NS, and a function that combines them. So let's see what they do. It's got a names array here. And again, I'm doing my little trick with the numbers. So this one emits a number. I'm taking only how many elements I have here, so in this case 4. And then for every value coming in, I'll return a random number. So this one here, that's why it's called R&D, just returns a random number. This one here returns the name. So it splits out the array and gives me 4 events, 1 for each name. And the combinator function takes A and B, so random number and the name, and says B name, and spits out a random number. There we go. Pretty straightforward. And again, I don't know about you, but I've been using this a fair number because when you do anything more complex, you have multiple streams to combine. One other thing, since we talked about async subjects, sometimes you have an API call that returns something, let's say user data. And you want to use that user data in multiple ways. Let's say you want to create cookies from it, and then you want to populate a database with it. So you need to kind of take that data and use it in multiple ways, and in the end you want to come back together. So here I'm just taking an async subject and just putting a string in, calling the uncompleted. So now the async subject contains raw data. I'm going to subscribe, or I'm going to put a map on it, and this one here is just a fancy way of reversing the string. I'm creating an array, I'm reversing it, and I'm joining it back again. So now I have my async subject, and I've got this other observable. These are my two functions, or my two observables, and then my function only says whatever is in the async subject reverse is that. So there we go. So this is what's in my async subject, and this is what's coming out of the async subject being processed by this map. So basically what I've done, again, is I have my data, I'm going to keep it, but I'm going to keep processing it into something else, and then in the end I'm going to zip it back together. In another way, I'm sorry if that's boring, but I thought this was really interesting when I first hit on it, is that I used to think of, okay, the zip takes two streams and I'm writing a custom function to combine them. The other way to think about it is you have a function that takes two parameters and you pass the data to it through streams. So let's see how that would work. Let's say you have some encrypted payload where the first is a key and the second one is the actual payload. And you have a function that does your decryption, and it uses a key and the encrypted data. So the first thing you would do is you take your encrypted data, you split out the key, right? Split on the dot, get the first value out. And then with that, you go supposedly to some other server and get the actual key for that key ID. So now this key variable has an observable with the key value in it. And then for the data, we just do the same thing, except for getting the payload. So now I have my key here, my data here, and two observables. All I need to do is pass it to the variable or to the function I wanted to populate in the first place and just keep going. It's a very subtle difference, but you know, once I figured that out, a whole new world opened for me. So hopefully it does for you too. So doing one thing or another, right? Ifs, who writes them more than 10 times a day, right? We're using them all the time. Rx.js has an if operator, and what it takes is it takes a function that either returns true or false. If it's true, it returns, right, it runs the true path, otherwise it runs the else path. So true path here is you check the box, else path, you didn't check the box. In my condition, and forgive me, this is an impure function, my condition basically says, is this checkbox checked? So didn't check the box, you did check the box, and that works pretty well. Problem is, we start our sequence out with the if. What happens if we have some data and now we want to make a decision based on what's in the stream? So first naive attempt is, I'm just going to return some value. I'm going to use the operator, you know, with my function. So here I'm returning some value, and if this one would be, some value would be true, so I would be doing opt1. Well, it doesn't work because it's not meant to do that. It's always meant to start off an observable. Okay, great. Let's try something else. And this goes back to the whole async thing. Let's just say that we do our calculation, and then in the end we subscribe and we populate a value out here in scope with true. And then our function will pick that up and we do our if, and that should work, right? Except that it doesn't. Did not work. Did not work. And the reason being is that this runs asynchronously, so you never know when this has actually run as opposed to when this function gets evaluated. So you're always running into race conditions. If you wanted to do if properly within a stream, we'd have to do something like this. So here again, we have our two observables, yes or no, and we just return a value because I just need an event right now. And I'm going to flat map it. I'm going to say if this thing is checked, return this observable, otherwise return this observable. So that's why we're having to use a flat map here. And now this works. Unchecked, value was true, unchecked. This is a little cumbersome, so in about 5 minutes I'm going to talk about how you can write your own operator where you can see in your stream, unless or if this is happening, do something else. There's another problem with if you're not careful. Again, we create our two observables, and this one here goes and does a jQuery AJAX request. Our test function returns true, so this one returns true, and you would expect S1 to run. And it does, but this promise is just listening to a promise coming back, to some data coming back, which means that even if this is true and S1 never should run, this jQuery execution still runs, because that's how it starts out. Right? You start out with it, and it comes back with a promise, and then it goes. So if you wanted to avoid that, there's another operator called defer, which is essentially a factory function. So this, as you subscribe, if S2 is true, defer gets executed, and then you do your API call. So again, minor detail that can trip you up when you're debugging things and saying, why is this API call running? It shouldn't be running. So just a little gotcha. Okay, just real quick, how to make your own operators. One thing I ran into is sometimes you start writing code, and this one here is where I have some cookie, and I want to validate it and decrypt it and do all kinds of things with it. So in this case, it doesn't matter really what it is, but I have these 3 steps. I'm checking a hash somewhere, I'm decrypting my cookie, and then I'm validating it. And now I'm writing this all over the place. It's not dry, and I can't test it as a unit because it's really a unit, right? I do this 3 steps every single time. What I really want is, I have my cookie, and then I'm going to decrypt my cookie in that function. Much easier to read rather than, what the hell is this? So, how do we start out? Rx gives you a function that creates a new observable. And what it does is it takes your function and passes it an observer. So that means it passes you the next step, essentially. So what you do then is with the next step, you call the onNext, you stick the value in, and you can do that however many times, and then you can also call onCompleted. Does that make sense? Any questions about that? Too many questions about that? Anybody understand this? All right, let me just go over it again. So Rx observable create is an Rx function. And we're providing basically a constructor function that gets passed in all these steps here. So in this one, the observer would be actually the next method. So that means that we can stick data into it. Let's just play with it for a little bit and see if that makes any more sense. So I'm using the exact same construct. Here's my observer. And since I know I'm going to get an observable back, for now I'm just going to go mock it up and saying I just get some kind of value. And to propagate that value, or actually let me say this another way. To think about this operator is there has to be a way in. I need to get some data from before. I need to do some processing. I need to pass the data out. So this one here is how do we pass the data out? We get the next observer. We take our sequence, and as we subscribe, we pass the 3 events on to the next one. So let's look at the way in. So you notice these are the lines that we had before that we wanted to abstract out. This now is the way in. So that's your previous operator that gives you the data, which is again an observable. So we can map, flat map, flat map, just like we did before. And here's my friend the async subject again. Since some of these are asynchronous and take some time, I want to not rerun this every single time, but I want to go and stash the output. So I'm doing my operation. I'm going to stick it into an async subject. And that's my way in my processing. So now the whole thing is, here's the code we just had before on the way in. Get our data, process it, put it into the async subject. And here now what I had before with returning a value, we take our async subject and we subscribe to it, and we pass the data to the onNext function on the observer. So that's how we get our data in, we process it, and we pass it down to the observer. And again, as I said, so now this is how you would use it. You do the cookie, you do your decrypt cookie, and then since this is an async subject, now you can use that stored value multiple times without rerunning all your processing all the time. Okay. Unless operator. Are you guys ready for this?
I have a question.
Yeah.
Back a couple slides when you did your create, is that pretty much acting like a replay observer or observable? Sorry, subject? Replay
No, all it really does is it creates a new observable. So if you think about what's happening is you have your observable with a value in it, and as you pass a method in, or a function in, the value gets mashed with your function, and you get a new observable. So what this create does is it's basically the process by which you create that new observable, and now you need to populate that observable with a value. Right? So that's what the onNext does. Right, so we're creating our observable and we're returning it. And then what we're doing here is basically into the observer, we're passing down the onNext, unerrand, onCompleted. So we're just creating basically a new container. Did that answer your question?
I'm just looking all up.
All right.
I just need to look a second.
All right. You know what? I think I'm going to go skip that. Just want to touch briefly on two more topics. If you have your own custom operators and you want to go test them, this is a whole lot of code. It's written in Jasmine, but the way to do this is to basically start off with your value you want to process. And this is one that I skipped, but the principle is the same. You use your operator, and then you subscribe to it. So in this case, we're testing here whether the alt function was called, and then we're done. But the main thing to keep in mind is that if you test your custom operators, you got to use in your test.
Question.
Yeah.
So that custom operator you created, you could replace unless with your own operator.
Yeah, you know what? Maybe I should just go through it. My apologies. But you know how I said with the if, you have to do the flat map and then do the if inside. It's kind of cumbersome. How many of you have Perl experience or know what Perl? Right, so there's, at least me, it always gives me ulcers when they have a method called unless. And I'm just, what is that? Every time you kind of get this brain twist of, unless this, so if this is true, does this happen? Or what? But anyway, I couldn't use if because that's already kind of taken. So let's start off writing an unless operator. So the goal is, I have my data stream, and unless something is true, I want to keep going. Otherwise, I'm going to call some other function. So just like with the if before, we have our predicate, so the function that we use to evaluate what to do. And then if this one returns or indicates that we shouldn't continue, some alternative function we want to go and run. So let's start off with the processing part first. We're getting some value from the previous operator, and we're passing that to the function that we're being passed. Right. So this one returns true or false. If it's true, we're going to call the observer on the next one and pass it the value. Just pass it right through. Otherwise, we're calling the alt function and we do nothing with the observer. So now what happens if this predicate function, let's say, throws an exception? We're not accounting for this right now. So we wrap it into a try catch, because if any of this fails, clearly there's an error and we should propagate the on error event on the observer. So that's pretty much the processing part. The processing needs to happen in an observable, so we're going to wrap it again into our new observable. And on the way in, so this here again is the value of, or the observable that gives us the value. And this is just like the good old self equals this trick, you know, for scoping. So what we're doing is we're taking the previous observable, we subscribe to it. And that means we're getting the next data point. When the next data point comes out, we're passing it to onNext, which is our little processing function. So if predicate returns true, we're passing the value on out of this operator into the next operator. If this one returns false, we'll just execute the other function we've been given, and we don't do anything else. So that means everything below will not execute. So this is kind of like an if, right? You got data in, you check, is this true? If yes, keep going, otherwise do something else. And this is how you would do it, test it. So you return false, and what is that predicate? Mock predicate, so we're checking whether false equals true, which is false, so we would expect to have our alt function called. So we're basically checking whether alt func is being called. As I mentioned before, we're not doing an onNext event, so that would be a failure if we got that. If we get an error, it's a failure. And at the end, we check whether the alt function has been called, and we're done. And again, the main thing to take away here, this is a lot of code, but is you need to subscribe to it, otherwise you won't kick off your sequence. So real briefly, at the last time somebody asked me about how I organize my code, and I didn't really have a good answer because it's a year ago and I've been just, doing more and more of this stuff. Originally I had all the operator functions in the object that I've been using. So I process and all the functions that I pass to Rx are in the same object. Makes it not very usable. So now I've gone to creating a separate module in Node that has all the functions in it, which is great, makes it perfectly reusable. The problem is now I have a file that has 1,800 lines of functions in it, so it's really, really hard to keep track of. So my next approach will be to create two modules, one for my custom operators and one for the functions that I keep using in Rx. And they're going to be grouped by functionality. And as an added bonus, what I'm probably going to do is have one module that includes all the other ones, kind of like a front for it. So I can organize my code but still have access to all the operators. Anyway, it was a lot to take in. Here's some resources if you're more curious about how to do things. The Rx.js documentation is so-so. It gets better the more you know, but then you need less documentation. This one here is a really fun way to play with, and if you haven't done Rx, I would encourage you, go to this site and go play with it and see what's happening. It's a really interactive way of doing things. So in summary, I've talked about pure functions and querying, and that's something you can use anywhere and everywhere, but especially in Rx, it's really helpful. Talked about subjects, different ways how we can do our conditional execution, and how to write your custom operators. And that's all I have. And if there's questions, or before we get to questions, actually my company, Dow Jones, is currently hiring. We're looking for senior developers. So if you have any questions about that, I got cards up here from people, or just come down and talk to me, see how it is. We got data science people, we got website building, we got market data, we got a whole slew of different varieties. So with that, if there's any questions, fire away. Yeah?
So since Rx.js basically comes out of the need to be dealing with asynchronous issues, it's very much rooted in asynchronous programming. I noticed a lot of overlap between the ideas of Rx.js and the concept of promises, at least in the fundamentals,
Mm-hmm.
like chaining and adding, just passing more and more methods to your promise object, you just pass around while you're waiting for the values to finish into your promise object.
Yeah.
And a couple others that I can't remember off the top of my head, but I was wondering if you could clarify, or the on-next as well. But I was wondering if you could clarify a little bit what the big picture differences are between asynchronous programming as Rx.js does it and asynchronous programming as promises can.
That's a very good question. I'm not sure I have a really good answer for you. I mean, you're right. They're very, very similar, right? And the only thing is,
Speak up.
yes, so if I just may re-say what you said. So he said that that observables are cancelable, whereas promises are not. Once you kick off a promise, it's running. You can't cancel let's say the API call. That's a good point. The other thing is, I'll get to you in a second. Yeah, and the other way is just,
So the observable is kind of like a promise that you can resolve again and again and again over time.
yeah, I mean, so
You're still mostly staying within the value paradigm of only using one value and just passing it along.
right. I mean, the interest, right. I mean, basically you're passing values through, and in that, if you have a promise chain, it's the same thing. What I like about Rx, and this is just the way I feel, honestly, is that you have all these different operators and they tell you what's happening. If you have a map, you know that it's some local processing. If you have a flat map, usually that means you have some more, an API call or some other observable is being returned, something more complex. And I think composing with Rx.js is more straightforward and easier to do. Rx also provides you with a lot of out-of-the-box functionality like delaying things or buffering, retrying. So you go through, something fails, you do and retry it multiple times. But yes, I mean, conceptually you do things asynchronously, and Rx even accepts promises. You can create an Rx stream from a promise. And yeah, your cancel point is a good one. I didn't think of that. Sorry, did it answer your question?
Yeah.
Otherwise, just come by and we can chat more. I love talking about this stuff.
One thing to look forward to is that we're versus JavaScript, so you're going to get stuff like async await and potentially stuff like cancel tokens, which actually kind of accomplish the same kind of goal, as well as observables, which probably have the same next kind of continue and error kind of rate. If you look at something like Rx, like it gives you a lot of flavor, just kind of like Lodash does, but now a lot of things that are in Lodash are in basic native JavaScript. So moving forward, JavaScript is progressing, but we still have libraries like this that give you a lot of sugar and a lot of help going forward.
Yeah.
It's kind of cool stuff to look forward to. So you can just kind of see going into the native language.
Yeah, and Yeah, as you said, so somebody here in the audience said that, you know, ES6 has async await, or there will be async await and other asynchronous things, but oops. Yeah, it essentially is the same thing, and I'm sure you could do a lot of the things they can do in Rx with just promise chains. To me, it's just having those different operators that tell you more about what's going on. Any other questions? Yeah.
Have you ever started writing behavior in Rx.js and then found that as it evolved, the sort of conditional control flow that you needed became extremely complicated to implement in Rx?
Sorry, I have a really hard time with this noise. Can you speak up, please?
Control flow capabilities of Rx, have you ever kind of noticed what you can do there without a convoluted code structure?
Yes. Yeah, so the question was if there's ever convoluted code structure when you have branching and control flow things. Yes, that's one of the things that you have to watch out for. I mean, I've had some things, even this example that I showed about, you put something into your async subject and you keep it there and you do some other processing. At some points I had 3 streams off of the same async subject. So yes, that's potentially a downside, but I think you can probably abstract that out to make it more readable, but yes, control flow is an issue. Yeah.
Is there anything inherently asynchronous with observables? For example, if you create an observable from an iterable, like an array or something, and then you map that out, does that get executed immediately, synchronously, or is there inherent asynchronous?
It's inherently asynchronous. So behind the scenes, Rx.js uses a scheduler. So everything you do is asynchronous. Even if you have an array and you keep processing it, it's all asynchronous. And so of course the obvious next question is, how about performance, right? Because if you do all the scheduling and extra stuff, it's not as fast as if you wrote it straight up in a for loop or something like this. But I think the benefit of having this clean code in this functional paradigm outweighs writing a really complicated for loop. But yes, everything is asynchronous. Good questions. Anything else? Yeah.
Are there any garbage collection issues with it, or does it just constantly chew up memory, or is there a way that cleans up?
Everything should be. I have not. Let me answer this way. So the question was about garbage collecting and problems. I have not run into those issues. However, JavaScript, it depends on how you write your code. Right? You have to be really careful to avoid circular references in your objects, because that's really the main thing for memory leaks. And as long as you don't do that, and there's no more reference to your objects, it'll get garbage collected. So I haven't seen it. Yeah. Most of the, as I do processing, it's definitely CPU bound, but there's a lot of processing going on. So yeah.
Do observables work nicely with generator functions? Can they
I have
generator function with one?
I have not tried that. It's an interesting thought. I'm not sure if they're compatible with the interface, but I'll go home and try it out. Come back to my next talk. It's the NodeMN, so maybe I'll have an answer for you by then.
I think Dan's got a question for that. You look at every problem in the way of how do I fit this into functional reactive model, or do you see particular classes of problems that particularly apply themselves to using this kind of pattern?
So if I understood your question correctly, with all this bag rustling here, is whether, or yeah, I think the question.
Do you think this is powerful enough that most problems, particularly involving data manipulation, end up fitting into this kind of pattern? Like, does Rx.js need to sort of become your hammer that you use for everything, or is there a particular problem class that particularly lends itself to this, and if so, like, what is that?
Right, so I can tell you when I'm not using it. If I can write a simple function that uses, like for instance, you mentioned arrays, right? They have maps and filters and reduces. If I can write it that way, definitely go that way because it's going to be much faster in your code. Also, certain things, if you only have 1 or 2 transformations in there and you don't really need to do Rx, I don't see a need. So to answer your question, whether it's my hammer that I use for everything, the answer is no. There's certain things when I have some really tricky processing problems. For instance, again, going back to Auth0, since I've worked with this, you get called with a code, you exchange the code with an API call. That comes back, gives you an ID token. Now you go and exchange that ID token for a delegate token with another API call. And you go and get that, and then you keep processing on this, and you set cookies, and you update databases. So for that kind of stuff where you have really a top-down flow, where you have a nice sequence, this is perfect. It makes your code really readable. All your functions are reusable all over the place. So for that, I think it's perfect, but I wouldn't use it for everything. No. Yeah?
What program do you use to present with that allowed for live code execution?
Plain HTML, JavaScript. It's a library called Reveal. And yeah, I just have a separate file that has the code in it and redisplay the code and then just push it out. All right, well, thanks very much. I hope it's helpful.